Today we're going to look at how to find two ratios that describe the same relationship. So we have looked at 3 ways to write ratios. Now we're going to focus on all these different ways we can represent ratios in 2 different diagrams and tables. So we've looked at the tape diagram. The next visual for ratios is called the ratio table. So that's our focus today. So when we're creating these ratios that describe the same relationship, we call them equivalent ratios. You're going to see a lot of comparisons here that you see with equivalent fractions. Very, very similar. So we're going to use adding and subtracting, we're going to use multiplying and dividing, and then today we're going to focus on organizing these equivalent ratios in ratio tables. So here's how this works. We have 2 ratio tables down here. This one is showing pens and pencils. So we have a couple of options in this table. This is a really good one to show us the different structures. So the first one I'm going to show you is with the adding and subtracting. So if I want to add, I would add 1 up here, and I would just add 1 every time since I started with 1. Okay, so 1 plus 1 is 2, 2 plus 1, okay, that's going to give me the 3. Okay, so then down here, I have a 3, so I'm going to add a 3 here. And then I'm going to add another 3 here. So 3 plus 3, this is 6. 6 plus 3, there's the 9. Okay, so that's like saying maybe I'm making some lemonade, okay, and I add a cup of lemon juice and then 3 cups of water, okay, but I want to make more. So I add another cup of lemon juice and 3 more cups of water. So you always keep that ratio the same. In this example with pens and pencils, maybe I decide to give each of my friends 1 pen for every 3 pencils they have. Okay, so then maybe I want to do that again. I'm going to give them 1 more pen, 3 more pencils, then 1 more pen and 3 more pencils if I want to keep that ratio the same. So you can also look at this using multiplication. And what I could do is I can see to get from 1 to 3 here, I multiply by 3. 1 times 3. Okay, so then that should be true of all of these. 2 times 3. 3 times 3. And so on. Okay, let's look now. Then it says, skip this last part here. We're going to write the equivalent ratios. So now this is saying, do we understand what those mean? So we can look at all these structures in this table, but when we talk about the equivalent ratios, that means, okay, what are the ratios we came up with here? So what I see is we started with 1 to 3. Then we came up with 2 to 6. And then 3 to 9. So these 3 ratios are equivalent ratios. Okay, let's try this next one. So this time we're going to focus on the multiplying aspect here. So we have 4 dogs, 6 cats. So that's our ratio, 4 to 6. So what I'm going to do is say, well, when I look at this, to get from 6 to 12, I multiply by 2. So think about when you have fractions. Whatever you multiply this number by, you multiply the other number by. So if I did 6 times 2 here, I'm going to go up here and do 4 times 2. So that number becomes 8. Okay? But then it changes a little bit because now I'm trying to get to 24. So to get from 8 to 24, I need to multiply by 3. So that means I need to take 12 times 3 to get this number. So I end up with 36. So my 3 equivalent ratios this time are 4 to 6, 8 to 12, and 24 to 36. All right, go ahead and pause your video and then try the 2 tables down at the bottom. So fill in the values and then write your equivalent ratios. Unpause to check your work. All right, the plantains and bananas. Okay, I ended up with 4 to 3, 8 to 6, and 12 to 9. Okay, so you can think about adding 4 and then adding 3, or just do 4 times 2 and 3 times 2. Okay. Over here, 5 to 4, 10 to 8, and 40 to 32. Okay, again, you can add 5 and add 4, or do 5 times 2 and 4 times 2, then 8 times 4 and 10 times 4. All right, go ahead and flip this over. Okay, now we're going to use our ratio tables, and we're going to use that information to solve some problems here. Okay, so it says the nutrition facts label on a box of crackers shows that there are 240 milligrams of sodium in every 36 crackers. Okay, so here's our ratio. So 240 milligrams of sodium in every 36 crackers. So we want to compare sodium to crackers, so I'm going to create a ratio table. And it doesn't have to be super fancy, it can just be a quick T-chart. You can even create your ratio tables vertically if you want to. I'm doing them horizontally just because I don't have a ton of room vertically, but either way works. Okay, so I'm going to label what I'm comparing, sodium, and I put in milligrams so I don't have to write that unit every time, and then crackers. If you can draw your lines fairly straight, it's okay if you don't use a straight edge. It's a pretty informal table. Just make sure that they're not super, super crooked. It's okay to take out a straight edge, though, if you prefer. Okay, so I'm just going to make a simple T-chart. Just draw a few lines. If we need more, we can add more as we get going here. Okay, so first thing we want to do is fill in what do we already know. Well, we know that there's 240 milligrams in 36 crackers. Okay, so I'm going to put 240 next to sodium, 36 next to crackers. That means if you eat 36 of these guys, that's what I'm snacking on, then you're going to eat 240 sodium, 240 milligrams of sodium. But we're going to say, but you eat only 15 of them. That's a little bit more reasonable. You only eat 15 of those crackers. So we're going to figure out how much sodium you consume if you only eat 15. So our goal is to get from 36 to 15. So we just have to do some multiplying and dividing until we get to that point. So the first thing I notice here is that, well, 240 is a pretty big number, so I may not know everything you could divide it by, but I do know that they're both even numbers. So I'm going to start by dividing it by 2. You could divide it by something bigger if you wanted to, but I'm just going to start there. So I'm going to do 240 divided by 2. That's going to give me 120. 36, I'm going to divide it by 2. That's going to give me 18. So you don't always have to do these the same way. I just started with 2 just because I know that they're both even numbers. Okay, so it's okay to use something bigger. But I'm not to 15 yet, so I need to go again. So when I look at 120 and 18, I know that those are both divisible by 6. Okay, and so I'm going to start there. Okay, that's actually going to be my GCF. I can't divide them by anything bigger. So I'm going to go divided by 6 up here. I'm going to end up with 20. And then I'm going to divide by 6 down here. And I get 3. Okay, again, we want this number to be at 15. So if I want 15 here, I do know that I can go from 3 to 15. I can switch to multiplication now and do 3 times 5. So then I have to go up here and multiply by 5 to get 100. So if I look at this now, if I eat 15 crackers, I consume 100 milligrams of sodium. So remember, when we write our complete sentences, we restate the question. How much sodium do you consume? You consume 100 milligrams of sodium. All right, now we're going to say, I'm not quite done eating my crackers. I'm going to keep snacking over here. So now I'm going to say that I want 21 crackers. I'm going to eat a little bit more. Okay. So now we want to figure out, well, now, how much sodium am I eating? If I just keep going, I'm going to eat some more crackers. So we could create a whole nother table, But we could also use the problem we already have, because what I can do is I can look up here and see, well, 18 plus 3, that's going to give me 21 crackers. So instead of recreating an entire table, I can just kind of write this out. Well, there's my 21 crackers. So if I add those two, I need to add these two to get my amount of sodium. So what this tells me, how much sodium do you consume? Well, if I eat this many crackers, I'm consuming this much. So I would say you consume 140 milligrams of sodium.